So on this next one, make sure that you have your diagram drawn correctly. So I started with my isosceles triangle, and then I connected it to another isosceles triangle in the back. So the trough was 10 feet long, so I labeled the 10s. And it's 3 feet across the top, so I labeled the 3. And it has a height of 1 foot, so I labeled height as 1. And then this rate at which it's filling, I know that's a volume because I can tell it's got a cubed in it. So that's a dV/dt, and that I'm supposed to figure out how fast the water level is rising. So that would be change in height when water is 6 inches deep. Now, after the last problem, hopefully I'm paying attention to units and knowing that, oh, they actually matter. So I need to make sure everything matches, and I get over here and I go, oopsies, they're trying to pull a fast one on me. They used inches, so I have to change it to feet. So I'm not going to use the 6 inches. I'm going to use the half a foot. So now I need the formula for the volume of this triangular prism, which is the area of the base times the height. And since the base is a triangle, I would be doing 1/2 little base times little height. And then this height here is the 10. Now keep in mind that as I fill this trough up, the little base and the little height on this triangle, of course, are changing because the water level is different every time. Like it might be here, and so the base and height definitely aren't 3 and 1, and it might be here, so the base and height definitely aren't 3 and 1, and it might be here, so they're not quite 3 and 1. So those are changing, so I need to leave those as variables. But this height, connecting both bases, both triangles, that's constant, so I can leave that 10 in the formula. So really I have 5 base times height. Now again, I would like to have this equation in a single variable, and since I'm supposed to find dH dt, I would like it all in terms of height.